Hi, my name is Kepsi Richie and welcome to my channel. Today our discussion on binary operation will be on properties of binary operation. Before the video ends, I will introduce you to the properties that a binary operation may have. Then we will learn how to prove all these properties. This will be a very interesting engagement, so please come along. So we said that the binary operation defined on a set of real numbers may have this following property. One, it can be commutative. So may have a commutative property, may have associative property, may have a distributive property, or the closure properties. What do we mean by commutative property, associative property, distributive property, and a closure property? We'll learn how to prove them one after the other. So we start things off with the commutative property. So we say a binary operation star defined on a set R of real numbers is said to be commutative if A star B is the same as or is equal to B star A, where A and B are all members of real numbers. So if a binary operation is defined on a set R of real numbers and we find A star B and the value of A star B is the same as B star A, then we say that the operation defined on that set is commutative. So how do we prove that? So let's look at our first question. They say a binary operation star is defined on a set R of real numbers as A star B equal to A plus B minus AB. Show whether or not the operation star is commutative. So what do we say? We say that the operation star is said to be commutative if A star B is equal to B star A. So remember, A star B is giving us A plus B minus AB. So our B star A will be equal to B plus A minus BA. We can rewrite this as A plus B minus AB, and it will not change the meaning of the statement or the value of it. So you realize that A star B is equal to A plus B minus AB, and B star A is also equal to A plus B minus AB. Then we can conclude that since A star B is equal to or is the same as B star A, the operation star is commutative. I hope you get that. This is not anything difficult. So just find A star B or find A operation B. If it is the same as B operation A, then the operation is commutative. So let's look at our second question. They say a binary operation delta is defined on the set R of real numbers as A delta B is equal to A squared plus B squared. Show whether or not delta is commutative. Remember, A delta B is equal to A squared plus B squared. And we say that the operation delta is said to be commutative if A delta B is the same as B delta A. So let's find A delta B A delta B will be A squared plus B squared already given to us. Then B delta A, that will be equal to B squared plus A squared, which we can rewrite as A squared plus B squared, and to not change the meaning of that statement or the value of it. So realize that our A star B is the same as B star A, all equal to A squared plus B squared. Then we can say the operation delta is commutative. I hope you get that. So this is not anything difficult at all. So please, you can pause the video and try solving the third question on the board, which reads that the binary operation that is defined on a set R of real numbers as x operation y is equal to x minus y plus 3xy. Show whether or not the operation is commutative. So please, you can now compare your answers with mine. So remember, x nabla y is equal to x minus y plus 3xy. And we say that the operation is commutative if x nabla y is equal to y nabla x, where x and y are members of real numbers. Okay, so our x nabla y will be equal to x minus y plus 3xy, which is given to us. Now y nabla x will be equal to y minus x plus 3yx. So when we rewrite this, we can have negative x plus y plus 3xy. That's y nabla x. Now compare this to this. You realize that they are not equal. Whilst x nabla y is equal to x minus y plus 3xy, the y nabla x is rather negative x plus y plus 3xy. So they are not the same. So we can say that x nabla y is not equal to y nabla x. Therefore, the operation nabla is not commutative. Is not commutative. I hope you have the same answers with mine. So enough of the commutativity. Now, how will you know a binary operation defined on a set is associative? So the next one is how to prove associativity of a binary operation. So now let's look at the associative property. So we say a binary operation defined on a set of real numbers is said to be associative if A star B star C is equal to A star B star C, where A, B are in the bracket and the B, C are also in the bracket. So after a binary operation defined on a set of real numbers is investigated and A star B in bracket star C is equal to A star in bracket B star C are the same, then we say the operation defined on the set of real numbers is associative. So now we take some sample questions and see how we prove that. So let's see our first question under the associative property. They show whether or not the binary operation delta defined on a set R of real numbers as A delta B equal to A plus B plus AB is associative. Remember we said A delta B is equal to A plus B plus AB. We also say that the binary operation delta will be associative if what? If A delta B delta C is equal to A delta B delta C. So now let's deal with our A delta B delta C. So remember, A delta B is giving us A plus B plus AB. So we can say A delta B is A plus B plus AB delta C. So now solve this. So this will be treated as 1. So like all this as A and this as the B. So A plus B plus AB delta C will be this, that's A plus B plus AB as the A plus C as the B, then plus A plus B plus AB times C as the B. So when we expand this, you get A plus B plus AB plus C, then plus this will multiply this AC plus BC, then plus ABC. When we rearrange it, we get A plus B plus C plus AB plus our AC plus BC, then plus ABC. That will be A delta B delta C. So we can say A delta B delta C is equal to A plus B plus C plus AB plus AC plus BC plus ABC. So that's for the left hand side. Now the right hand side, that's A delta B delta C in brackets. So in solving for the right hand side, that's A delta in bracket B delta C. We'll deal with what is in the bracket first. So you can have A delta B delta C will be B plus C plus BC. And with this, now this becomes our A, then the whole of this will be B. So in place of A, we substitute that. In place of the B, we substitute this. So we have A plus bracket B plus C plus BC, then plus A, which then times our B, which will be this, B plus C plus BC. Now we expand and polish. We have A plus B plus C plus BC for this. Then this will multiply A plus B, A times B will be AB, A times C will be AC, then A times BC will be ABC. So we can rearrange this very well as A plus B plus C plus AB plus AC plus BC, then plus ABC. So this is our A delta B delta C. So you realize that A delta B delta C is A plus B plus C plus AB plus AC plus BC plus ABC. And look at it. Look at our A delta B delta C in bracket, this one. That's the left hand side. It's also A plus B plus AB plus AC plus BC plus ABC. So let me copy that here. So our A delta B delta C is also A plus B plus C plus AB plus AC plus BC and plus ABC. So we realize that the left hand side is equal to the right hand side. So we can conclude that A delta B delta C is equal to A delta B delta C in bracket. So the operation delta is associative. I hope you get that. So this is how we prove the associative property of a binary operation. We'll solve another question on the associative property so that you'll be abreast with the concept. So let's look at our second question. It says binary operation star is defined on a set of non-zero rational numbers as A star B equal to A plus B all over AB. Determine whether or not star is A commutative, B associative. Please, you can pause the video and try proving it on your own. After that, you compare your answers with mine. So let's look at the first place. Remember, they say A star B is equal to A plus B over AB. So we say the operation star is commutative. Remember when we were doing commutativity, is commutative if A star B is the same as B star A. So let's find our A star B. Our A star B, which is given to us as A plus B over AB. And the B star A will be equal to B plus A over BA, which we can rewrite as A plus B over AB, and it will not change the value. So we realize that A star B is A plus B over AB, and B star A is also A plus B over AB. Then we can say that A star B is the same as B star A. So we say that since A star B is the same as B star A, the operation star is commutative. Now let's look at the second one. That's associative property. Remember, A star B is given as A plus B over AB. So we said the operation is associative. The operation star is associative if A star B in bracket star C is equal to A star B star C in bracket. So we can find A star B then star C. So this will be equal to, remember A star B is A plus B over AB then star C. So how do we find D star C? Remember, all this will be treated as A and this will be treated as our B. So any place we see A now, we substitute A plus B over AB. Any place we see B, we substitute C. So that will be A plus B over AB plus C for the top. Then all over A plus B over AB times C for the down. So now let's try simplifying this. Remember this, The denominator is over 1. So the LCM will be AB. So we have AB there. If this goes there, it will be the same, it will be 1. So times that will be A plus B. Then AB divided by 1 will be AB times C will be ABC. That's for the top. Then down, this is multiplying. So remember this is over 1. This will multiply this, multiply that. So we have A multiplying, C multiplying A, AC. Then C multiplying B, BC over AB. So we can rewrite this as A plus B plus ABC over AB times, now we reciprocate, so we get AB over AC plus BC. So this can divide that. We said this can divide this. What is left? We have A plus B plus ABC over AC plus BC. So that's our A star B star C. We had A plus B plus ABC over AC plus BC. Now we prove the other side of the equation. That's A star bracket B star C. And compare the two and see if they are the same. So we want to check the other side there, the right hand side. That's A star B star C in bracket. So this will be equal to, we'll do what is in the bracket first. So A star B star C will be, so any place you see A we substitute B, any place you see B we substitute C. So we have B plus C over BC. I want to find A star this. So now any place we see A we substitute our A, any place we see B we substitute the whole of that. So what are we going to have? We'll have A plus B plus C over BC all over A times B plus C over BC. Now we simplify. This is over 1. So the LCM there will be BC. BC divided by 1 will be BC times A will be ABC. BC divided by BC will be 1 times this will be B plus C again. All over. So this is over 1, it will multiply this, multiply that. We have AB plus AC all over BC, which we can rewrite as ABC plus BC, ABC plus B plus C over BC will reciprocate times BC over AB plus AC. So you realize that this will divide that. So we'll be left with ABC plus B plus C all over AB plus AC. So that's our A star B star C in bracket. Now you realize that A star B star C is ABC plus B plus C all over AB plus AC. Now let's look at the left hand side. The left hand side, which is A star B in bracket star C, is A plus B plus ABC over AC plus BC. So you realize that both sides are not the same. They are not. So since we realize that both sides are not the same, that's A star B in bracket star C is this, and A star B star C in bracket is this. Since they are not the same, that's since A star B in bracket star C is not equal to A star B star C, the operation star is not associative. I hope you get that. I hope you get that. So the next property we'll be proving is the distributive property. But before we prove the distributive property, let's look at this question. So they say a binary operations delta and star are defined as x delta y is equal to xy and x star y is equal to x plus y. We should evaluate 2 delta 4 star 3. So how do we do this? Remember, we deal with what is in the bracket first. 4 star 3, that will be x, substituting 4 in place of x and substituting 3 in place of y in star. So we have 4 plus 3. So this will be 2 delta, 4 plus 3 is 7, so that will be 2 delta 7. 2 delta 7, remember x delta y is xy, then 2 delta 7 will be equal to 2 times 7, which is equal to 40. Then we can say that 2 delta 4 star 3 is equal to 40. So since we got this understanding, when do we say that one binary operation is distributive over the other? So say when 2 binary operations star and delta are defined on a set R of real numbers, and look at it. And we have A star B delta C in bracket, and it is equal to, look at it, we are distributing the star over delta. So we say it's equal to A star B delta in bracket then delta A star C. If this side is equal to that side, then we say star is right hand distributive over delta. Also, if B delta C in bracket star A is equal to A star B in bracket delta C star A in bracket, then we say star is left hand distributive over delta. So the binary operation star is said to be distributive over delta if it is both right hand and left hand distributive. I hope you get that. So to prove the distributive, first you have to prove the right hand side distributive. You prove the left hand side distributive. If both sides are the same or both sides obeys the equation, then we say that one operation is distributive over the other. So now we take some sample questions and see how we can prove that. So now let's look at a question on the distributive property. Say 2 binary operations delta and star are defined on a set R of real numbers as x delta y is equal to x plus y and x star y is equal to xy. Show whether or not star is distributive over delta. So how do we do that? Remember, we said that star is said to be distributive over delta if it is both right hand and left hand distributive. So very important. So now let's prove right hand distribution. So right hand distribution. So right hand side distribution. So how do we do that? So star, they say we should prove star is distributive over delta. Then we have to prove that A star B delta C is the same as A star B in bracket delta A star C. So now let's pick the left hand side. That's A star B delta C. So how do we do that? Remember, we have A star, then we solve what is in the bracket first. That's B delta C. So x delta y is x plus y. Then B delta C will be B plus C. So we can say that A star B plus C will be A, so star one, X star Y is XY. Then A star B plus C. Any place we see X, we substitute the A in star. And any place we see Y, we substitute B plus C. So we say to be A times B plus C. And this will give us AB plus AC. So this is our A star B delta C. Now we take the other side too. That's A star B in bracket delta A star C and prove and C. So now we want to prove the other side. That's A star B delta A star C. So A star B, it means in star, any place we see X, we substitute A, and then Y we substitute B. So we have A star B will be AB. Then delta A star C will be AC. Now I want to find AB delta AC. Any place we see X in delta, we substitute AB. In any place we see Y, we substitute AC in delta. Then AB delta C will be equal to AB plus AC. So we can say that A star B delta A star C is equal to AB plus AC. Also, when we have A star B star C is equal to AB plus AC, both sides are the same, then we can say that A star B, A star in bracket B delta C is actually equal to A star B delta A star C. Therefore, or hence, star is right hand side distributive, is right hand side distributive over delta. Now we prove the left hand side too and see if it is the same, then we can draw our conclusion. So, since we have realized that star is right hand side distributive over delta, let's prove the left hand side distribution. So we say star is left hand side distributive over delta if that's if B delta C star A is the same as B star A delta C star A. So now we take this side, the left hand side, and prove that B delta C star A and prove and C. So in proving the left hand side of the left hand side distribution, that's B delta C in bracket star A. So we'll deal with what is in the bracket first. So B delta C, any place we see X in delta, that's the operation delta, we substitute B, and the Y we substitute C. So we'll get B plus C star A. Now, this, any place we see X in star, we substitute B plus C, and Y we substitute A. So what are we have? We have B plus C times A. When we expand that, we get AB plus AC. So realize that B delta C star A is equal to AB plus AC. Now let's prove this side. That's B star A delta C star A. So B star A delta C star A. How do we do that? So we go back to the star. So the star, the B star A, remember it will be AB. So AB, it will be BA, sorry. BA delta C star A will be CA. So when we have BA delta CA, we come here. So in place of X, we substitute BA, and in place of Y, we substitute CA. So that will be BA plus CA, which we can rewrite as AB plus AC, and it will not change the meaning of the sentence. So thus, we realize that our B star A delta C star A is equal to AB plus AC. And the first one, that B delta C star A, is also AB plus AC. So they are equal. They are equal. So we can say that B delta C star A is equal to B star A delta C star A. Hence star is left hand side distributive over delta. So what can we conclude? We realize that star is both right hand side distributive over delta when we prove that, and the left hand side too, it is distributive over delta. Then we can conclude that therefore star, okay, since star is both right hand side and left hand side distributive over delta, then it is distributive over delta. So like we proved, it is only right hand side and not left hand side distributive, then it is not distributive over delta. So look at the last property, which is the closure property. But before we do that, please remember to like my video, share my videos, comment. Your comment keeps me going. Also subscribe to my YouTube channel if you are here too. This will make my YouTube channel grow more, and I can share more mathematical content with you. Now with the closure property, we say a binary operation delta defined on a set T is said to be closed under T if A delta B is a member of T. So a particular set will be given to us, and two elements of that set will be defined on a particular operation. If the outcome of the operation is a member of the set for all values of, or for all elements of T, then we say that the operation is closed under the set T. So now we'll take a sample question and see how we'll go about it. So look at this question. They say a binary operation delta is defined on a set T equal to 2, 3, 4, 5 by A delta B equal to 3A plus 2B minus AB, where A, B are members of T. It's a copy and complete the table below. So this is the table. We are going to complete this table to find these 1, 2, 3, 4 values. Then it says show whether or not T is closed under delta. Then C, we should evaluate 3 delta 4 in bracket, delta 3 delta 5 also in bracket. So how do we go about it? Look at it. This place, that's 3 delta 2. So in this place, we will evaluate 3 delta 2. So our 3 delta 2 under the operation, that means any place we see A, we substitute 3 and B, we substitute 2. So I have 3 times 3 plus 2 times 2 minus 3 times 2. 3 times 3 is 9. 2 times 2 is 4. Minus 3 times 6. 3 times 2 is 6. 9 plus 4, that's 13 minus 6. 13 minus 6 is 7. And we can say that 3 star 2 is 0. So we just write our 7 here. The next thing is this. That's 3 star 4. So how do we do that? Our 3 star 4 will be equal to any place we see A, we substitute 3 and B we substitute 4. We have 3 times 3 plus 2 times 4 minus 3 times 4. 3 times 3 is 9. 2 times 4 is 8. 3 times 4 is 12. 9 plus 8, that's 17. 17 minus 12, that will be 5. So we just write 5 here to complete our table. The next one is this place, that's 4 star 2. And this 4 star 3. So our 4 star 2 will be any place we see A we substitute 4 and B we substitute 2. We have 3 times 4 plus 2 times 2 minus 4 times 2. 3 times 4 is 12. 2 times 2 is 4 minus 4 times 2 is 8. 12 plus 4, that will be 16 minus 8. 16 minus 8 is 8. Then we can write 8 here. The next one is 4 star 3. Suppose now. So let's find our 4 star delta 3. 4 delta 3 will be 3 times 4 plus 2 times 3 minus 4 times 3. 3 times 4 is 12. 2 times 3 is 6. 4 times this 3 will be 12. 12 minus this 12 is 0. So that will be 6. So we can write 6 here. So we are done completing the table. Now what reason are we going to give or to know whether delta is close under T? So the B aspect show whether or not delta is close under T. So look at the outcomes of the operation. If any of them happens not to be a member of the set T, then delta is not close under T. And you can see 6 is not a member of T. You can see that 6 is not a member, 8 is not a member, 9 is not a member, 0 is not a member. We have those reasons to give. So you say that since 0, 6, 7, 8, and 9 are not members of T, delta is not close. It's not close under T. It's not close under T. So that's it. That's the reason we have to give. So the last thing is that we should evaluate 3 star 4 star 3 star 5. So we are just going to use the table to evaluate that. So 3 star 4, 3 delta 4. 3 delta 4 is 5. You can see that. We say 3 delta 4 is 5. Delta. Now 3 delta 5. 3 delta 5 is 4. So 4. Now we find 5 delta 4. 5 delta 4 is 3. That will be 3. So we can say that our 3 delta 4 delta 3 delta 5 in bracket is equal to 3. Just by using the table. So we'll end it here today. Please, before you sign off, remember to subscribe to my YouTube channel if you are here too. Until we meet again, my name is Richard.